Good morning. Today, lesson 10-5 is mean absolute deviation. So what does this mean? Remember that mean is the average. Absolute means distance from zero. So direction doesn't matter is really what this absolute means. The average distance of change. Deviation means to change or to deviate. You may have heard of to deviate from the path would be to go off the path. So the mean absolute deviation is basically the average distance of change. What do we use it for? Well, when you find the mean of a set of data, that's your measure of center. To figure out if your data is consistent, which kind of means is it good quality data, then you need to figure out how much or how consistent the data is, or how close to the mean all the pieces of data are. And to do that, we find the MAD, the mean absolute deviation. So that's what we need to be able to do today. And honestly, this is a real world skill. If you're ever going to be in any kind of job where you have to do a study, learn from a study, read about a study, it's good to know this. If you're just in some kind of situation in your own life where you need to read a study in order to purchase the right thing, or you want to pick out something, you're probably going to read data. So knowing what this means helps you to be better at that. All right, so you've learned how the range and interquartile range describe the spread of a data set. Another measure of variation or change is the mean absolute deviation, or the MAD. So what I love about this book is that it has these step-by-step instructions, which are going to be great. So step 1, we find the mean. Here's all of our data points scored per game. And we need to find the mean of all those. So we add them all up and divide by how many there are. There are 6. 1, 2, 3, 4, 5, 6. And then we get 52. 52's the mean. Then to find the MAD, you have to find out how far each of these are from the mean. And one way you could do that is to plot them on a number line. And when you plot them on a number line and you identify the mean of 52, then you could see 53 is 1 away, 57 is 5 away, and 58 would be 6 away. And then 50 is 2, and 48 is 4, and they've already marked 46 as being 6 away. You don't have to do it on a number line, but a lot of students like to do it this way so they can just see what's happening. And then you find the mean of all these little distances that you found. So 6 plus 4, let's see if I write it out here, you'll be able to see it. 6 plus 4 plus 2 plus 1 plus 5 plus 6 divided by 6, 1, 2, 3, 4, 5, 6, is going to equal the MAD. Turn on calculator. 10 plus 11 plus 3 divide 6 was 24, so the MAD is 4. And who cares, Miss D? What does that even mean? Well, a small MAD means consistent. And you could even put a smaller MAD, means it's consistent data. Or it's data that maybe isn't accurate, as we've talked before. Remember, accurate might be, if you have a target, accurate might be hitting mostly close to the bullseye, where consistent means all the data points are really close to one another, but they might not be hitting the target. You want both, that would be the best. But this means that the data could be very consistent. All right, so let's try to do one. And again, all the steps are here for you. So when you're in your homework, try to go through these steps. If you can't remember them, open this back up and look at these steps. Remember, you have this physical book, but you also have this online. So we have the maximum speeds of 8 roller coasters. Here they are. Find the mean absolute deviation, or the MAD, of the data set, and then we'll explain what that means. First, we have to find the mean. So we add them all up and divide by how many there are. So we're going to say 58 plus 88 plus 40 plus 60, 72, 66, 80, and 48. And then we get divide 512 by 8, and we'll get 64. The mean speed of the roller coasters is 64 miles per hour. Then we got to find the distance between each of the value points. And again, you can plot them on a number line and figure out how far each of them are. I don't do it that way. I'm going to show you how I do it, but you're welcome to do it this way. If this way works for you and makes a lot of sense, awesome. What I'm going to do is take 64, take away 58, and I'm going to get 6. And then I'm going to do the same with 88 minus 64. And I'm going to get 24. 64 minus 40. 24. 64 to 60 I know is 4. 64 to 72 is 8. To 66 is 2. 80 minus 64 is 16. And 48 minus 64. But Misty, that's a negative. I know, but remember, they're absolute, so the negatives don't matter. It's just another 16. We'll add all those up and divide by 8. 6 plus 24 plus 24 plus 4 plus 8 plus 2 and 16 and 16. Divide that by 8 and we'll get 12.5. That's the MAD. So your book had done it here where they had found all of these and they have the same list that we have. And they got 12.5 miles per hour is the mean absolute deviation. Okay, cool. So what does that even mean? Well, what it means, the average distance of each roller coaster's speed is from the mean is 12.5 miles per hour. So what this means is that all the roller coasters that we had in our study are 12.5 miles per hour away from 64 or closer. So if you know that the mean is 64, you could have plus 12.5 and minus 12.5, and in this range would be most of the roller coasters. That's how fast they're going. That's all that means. Okay? Now, you're going to get to some where you have to compare the means and the MADs. And why you have to do that? Well, sometimes you need to know if the data is any good or not. All right, so let's work through this example. This will be our last one for the day. 2 driving schools use the same practice driver's test. Out of 100, School A had scores of blah, 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 and School B had scores of blah, 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 blah. Find the mean absolute deviations, then compare them. Okay, well, first we have to find the mean. So School A. Its mean is 81.2. School B. 77, 83, another 83, 81, and an 82. What? They have the same mean. Interesting. So now, in order to find the MAD, remember we have to find how far each of those points are away from that. So we're just going to take that and subtract the points. So we're going to have an 11.2, 81.2 minus 79. It's going to be 2.2. 80 minus 81.2 is going to be 1.2. That's going to be 0.8. And then 95 minus 81.2 is 13.8. So we add all those up. Divide by 5, because there are 5 of them. We get 5.84. 5.84 is the MAD. That means that these scores differ from the mean either more or less by 5.8 points. Okay, now let's do the same thing for school B. I have to find out how far they are away from 81.2. And we got 2 at 83, so that means 81.2 is only 0.2 away from 81, and 0.8, we already did that one. So 0.8 plus 0.2 plus, sorry, I got distracted. Now, do these numbers generally look smaller than these numbers? Yeah, which means your MAD is probably going to be smaller. 1.76. Yeah, it's smaller. Okay, cool. Who cares? Well, here's what this means. The mean absolute deviation for school blank is greater than, school A is greater than school B. This means the scores for school something are closer together and clustered around the mean. School B has scores that are closer together. The scores for school A are more spread out and not as clustered around the mean. Okay? That means the scores at school B, most of those students have a score really close to the mean, where at school A, you had one person do really well, one person do pretty poor, and then 3 people do kind of in the middle, right? That's all this means. All right, so find the MAD. It's a little extra work, but it's not difficult work. Subtracting and finding the mean is not super difficult. All right, good luck.